All right. Let's start with our lessons. Up to so far, we have covered all sections around arithmetic, geometric, and geometric sequence and series. So this part we have covered, and all the topics under here, they are in chapter 1. And one more thing we have covered is what is called quadratic sequence, quadratic and combination sequence. Quadratic and combination sequences, of which is also under chapter 1. And at the moment, we are in topic which is under chapter 2, which is called Euclidean geometry. So it's one of the chapter which carries a lot of marks. So Euclidean geometry. So under Euclidean geometry, this is what we have covered already. So we have covered a revision for grade 11. Full revision for grade 11 we have covered. As I've said the last time, so this revision, it carries 12 theorems, of which you must remember all of them. And I've done 2 proofs for under Euclidean geometry. So the first proof I've done with you is for proving that theorem, which talks about all right. So the first one is for the cyclic quadrilateral. So I've done this proof with you last week, of which you must make sure you know that proof, because it's very important. And then the second proof I've done with you is what is called the theorem for turn chord. So the turn chord theorem, we have done the proof of this. We also did the proof of that. And then now we also started with Euclidean geometry for grade 12, of which I've done the first part, which is called proportionality. So it's the proportionality theorem. Very, very important theorem. You must know that theorem because we're going to use it very often. All right, today I want to cover 2 important things. Actually, if time allows, we must just wrap up with everything about this chapter today, and then tomorrow we'll then have to focus on the questions around this chapter. So we can attend any question which requires the knowledge of this chapter. So that maybe next week I give you a test, and then we also start a new chapter. So today I want to cover with you a theorem which is called midpoint theorem, of which you can also do the proof, but this proof is not popular in exam, but we can do it for the sake of covering everything. And then the other one is what is called the equiangular, or let me use that other word. So we can have a midpoint and similarity. Yes, I wanted to remember this word. So similarity theorem, of which it also have a converse, of which you must take note of. And then the other important theorem under grade 12 is the Pythagoras, of which you have done the Pythagoras already, but it's also covered under a Euclidean geometry for grade 12. So it's the Pythagoras theorem. So you must also take note of that theorem. It's very, very important. So these are the three theorems of which we are left with. So if I cover these two today, and then it's going to be something, because we can just finish up with the Pythagoras theorem tomorrow, and we do questions about these theorems tomorrow. So now, with regards to what I've explained on the board, can you update me of what you have done from school up to so far? Which topic have you covered? I just want to align what you are doing with what you are doing from your schools. So I want to find out which topics have you covered up to so far from your schools?
We are still busy with the proportional theorem, Euclidean geometry.
All right, okay. And all right. And are you fine with this proportionality theorem? Because I think it's the crack of the matter in everything that you're going to do from here.
For me, sir, we haven't started with the proportional theorem.
You haven't started with proportionality theorem?
Yes.
Okay. Okay. So let me just remind you about the idea around this proportionality theorem before we go to midpoint theorem, because midpoint theorem, it relies on the proportionality theorem. Same with the similarity theorem, it relies on the proportionality. So you must know everything about the proportionality theorem before we go to the other theorems down there. So now let me remind you about the idea around the proportionality theorem. So let's say we have a triangle like this, where in this triangle we have A, we have B, and we have C. And in this triangle, we have another line that crosses there, of which this point we can call it G, and then that other point we call it E. So now, proportionality theorem, it says that if this is the assumption which you must make in order to establish an argument around the proportionality theorem. So it says that if DE is parallel to BC, then this first condition, it must be achieved, of which is the one which you must look for every time when it talks about the proportionality theorem. So DE must be parallel to BC. That's the first assumption. So if DE is parallel to BC, then proportionality theorem, it says that AD, or the ratio of AD divided by the ratio of BD, will be equal to the ratio of the other side of DE, in this case, is AE divided by EC. That's what proportionality theorem says. So if these two lines, they are parallel to each other, therefore the division of AD divided by DB or BD is equal to the division of AE divided by CE. As simple as that. So you must take note of this fact that if these two lines are parallel, then this is the case, of which the proportionality, you can write it in different way. It's not only that you're supposed to divide AD by BD and then divide on the other side by AE divided by CE. No, you may divide in any other way, depending on the kind of question you are dealing with. Let me just give an example of another way you can divide the proportion of the size. So if this assumption it holds, then you can divide the proportionality in this way. You can say, instead of saying AD divided by D, you can now say AB, the distance from here to there, divided by whatever distance, maybe AD divided by D, AD or BD, whatever. So, but in this case, let me use AD will be equal to, then on the other side, you must divide exactly the same way you have divided here. So you can see we have said AB this side, therefore on the other side, how are we supposed to divide? If on this side we say with the numerator is AB, what would be the numerator on the other side? If you're following this, what would be the numerator on the other side?
AC.
It's AC, yes, definitely. So that's how you're supposed to divide. So you say AC divided by, and the way you divide it on the other side, which in this case is going to be A. So, and then the reason which you must give in this case, because you remember this chapter is about giving reasons. So the reason which you must give in this case is that DE is parallel to BC, as simple as that. So this is how you establish the proportionality theorem, of which you are going to use in the next two theorems that I'm going to cover with you just now. But this idea around the proportionality theorem, you must not forget it because you're going to use it very often. Okay, then now let's quickly go to the second theorem, which is about the midpoint. So midpoint theorem is also established from that theorem that we have there of the proportionality. So let me explain the midpoint using the same diagram. So now for the midpoint, there are two assumptions which we have to make. So the first assumption is this is the assumption we made when we were attending the first theorem of the proportionality. So we now say DE is parallel to BC. That's the first assumption which you make. But this second assumption which you're supposed to make here, the second assumption is that AD must be equal to BD. This is the second assumption which you must make in this case. So this side, BD must be equal to the side AD. And if that is the case, it simply implies, this simply implies that AE will be equal to EC. So if AD is equal to BD and DE is parallel to BC, then that implies that even on the other side, AE is going to be equal to EC. But now there's something very interesting which I just want to explain now, which is very, very important. And that is the crux of the matter about the midpoint theorem. So the midpoint theorem, that if these assumptions are met, the first one, the parallel lines, the second one, this size, they must be equal, then DE, which is this line, so DE is going to be equal to half of BC. So the line DE is going to be equal to half of BC. So in other words, if we draw a line going down to BC, so this point here is going to be at the center. So the distance between this point to that point is going to be the same as the distance from here to there. So this is why we say midpoint, because the line that goes from here, cutting downwards to the side BC, is going to cut at the center. So which implies that this side DE is going to be equal to half. It's going to be equal to half of the side BC. This is all about the midpoint theorem. So please ask me questions if you did not understand something I explained with regard to the midpoint theorem. So this is all about the idea around the midpoint theorem, that DE is half BC. Are we all together with regard to that theorem? If you did not understand something, don't shy to let me know. I'm going to explain again because I want to make sure you all understand this.
So can you repeat?
All right, let me repeat again with regards to the second theorem, the midpoint theorem. So the midpoint theorem is derived from the proportionality theorem. Wherein from proportionality theorem, we say that the sides of the triangle, they are proportional to each other. So, which simply tells us that the division or the fraction you obtain from one side of the triangle is the same with the ratio you obtained on the other side of the triangle. For example, if DE is parallel to BC, that simply tells us that AD divided by BD is equal to AE divided by CE. As simple as that. That's what proportionality theorem says. Then now let's go to the midpoint theorem. So midpoint theorem is going to add from the proportionality theorem. So instead of having one argument, we are now going to have two arguments. So the first argument of which we have made from the proportionality theorem is that DE must be parallel to BC. That's the first one. This is the argument we have. And then the second argument under midpoint theorem is that the side AD must be equal to DO. Let me see, BD. So this is the second argument we're supposed to make under a midpoint theorem, that AD is equal to BD. So this distance here must be equal to that distance we have there. And if that is the case, we can prove, there's a theorem which proves that if this distance is the same with that distance, therefore AE is going to be equal to the distance EC. So AE is going to be equal to EC. And then that leads us to the theorem that we are aiming for here, which is about the midpoint. So the midpoint theorem, it says, of which you can also prove, there's a theorem which proves that. So the distance DE is equal to half of the distance BC. The distance DE is equal to half of the distance BC. What does that mean? So that simply tells us that the line that comes from E going downwards and cross BC is going to cut at the center of BC. So that's why we have this argument down here. DE is going to be equal to half of BC by the proportionality theorem. But that is true only if these two conditions are met. So the first condition is that DE must be parallel to BC. That's the first condition. And then the second condition is that AD must be equal to BD. And if AD is equal to BD, that simply tells us that AE will be equal to CE. So that is what is called the midpoint theorem. Whenever a teacher or anyone else tells you about the midpoint, they are referring to this equation that we have here. Nothing else. This is what is called the midpoint because it's cutting at the center. Midpoint is at the center of the two lines. It's the same as the midpoint you calculate when you're having two coordinates. Let's say we have coordinate A here and coordinate B here. So the midpoint is at the center there. So it's the same idea that we are using for this theorem. All right, can we quickly go to the third theorem, which is about the similarity theorem?
Yes.
All right, let's go to the similarity theorem. Which is also in the converse. Similarity theorem, it also has the converse. So we're going to do both of them. Similarity theorem. So now, similarity theorem, it talks about two triangles. You must be having two triangles, two separate triangles. So of which, let's say the first triangle, we're having angle A, B, and C, and then on the second one, we have angle D, E, and F. So this theorem, it tells us that if A is equal to D and B is equal to E and C is equal to F, then this is the conclusion that we're going to make. In other words, I'm saying if this angle, remember, these are two triangles which are not having equal size. They're not having equal size. This must be small, that might be big. But the angles are equal in this case. Angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. So if that is the case, then we can say that triangle ABC is similar to triangle DEF. As simple as that. This is the simplest theorem which you're going to come across in this chapter. Are we all together with regard to this theorem I've introduced just now? Are we all together?
I have a question.
Yes, you can ask.
With the similarity theorem, right? If we say angle A is equal to angle D, if we had to put figures in there, would it still be the same?
Repeat again.
If you're saying angle A is equal to angle D, right? And
Yes.
then we have to put figures like numbers inside the triangles, will it still be the same? Or will it
Yes,
be different?
it will be the same. It's going to be the same. It's not going to change.
Okay. All right.
Yes. So, and let me also emphasize something which is very important, that in most cases, to prove the similarity, you only have to have two angles only. So you can prove angle that angle A is equal to angle D and angle B is equal to angle C. I mean angle B is equal to angle E. So if you prove the two, then the last one is a given. It's a given that it must be the same. So if you prove that A is equal to D and B is equal to E, then the last one is a given. So when you do questions, don't prove all the theorems. I mean all the angles. You just need to prove the two, then the last one is a given from the angles inside the triangle, of which we have done that theorem already. As I've said, the similarity, it also has the converse. So let me just cover the converse, of which is the one that is very interesting. So the converse, it starts from this statement. It starts from the conclusion, which say if triangle ABC is similar to triangle DEF, then now I'm going to write a very, very interesting statement, which you must all understand. So if triangle ABC is similar to triangle DEF, then the ratio of AB is going divided by DC is going to be equal to the ratio of AC divided by DF, which is going to be equal to the ratio of BC divided by EF. Let me write that down. So it means AB divided by DE will be equal to AC divided by DF, which will be equal to BC divided by EF. This theorem is very, very important. So we can use these together with the proportionality or together with the midpoint. So I believe you know the idea around the proportionality, you know the idea around the midpoint. Now I introduce the idea around the similarity. So the similarity is saying, so if two triangles are similar, of which I believe you know that triangles can be similar if these three conditions are met. So if the two triangles are similar, then the ratio of AB divided by DE is equal to the ratio of AC divided by DF divided by equal to BC divided by EF. As simple as that. So it's a very, very powerful idea which you must take note of. Very, very important. Are we all together with regards to the similarity?
Yes.
All right.
Yes.
All right. Wonderful. Wonderful. There's just one theorem which we are left to do just now, which is about the Pythagoras. I believe you all know Pythagoras. So it's the simplest theorem that we are left with now. Okay, let's do Pythagoras theorem together. Okay, while I'm writing on the board, what do you know about Pythagoras theorem? What do you know about?
We use it where we're given a triangle that has a 90-degree angle.
Yes, very true. We must have 90-degree here, right? Okay, and can any one of you give me the formula for Pythagoras from this triangle here? So let's say we have side AC, AB, and then BC. What will be the theorem around that?
AC squared equals to AB plus BC.
AB squared plus BC squared. Very true. So this is what is called the Pythagoras theorem, and it's the one which I'm going to cover with you here. But now the only difference is that we are not going to do Pythagoras on one triangle. We're going to do Pythagoras when we are given triangles in this form. So it's a big triangle. A, B, C, and then now we have a line that goes from here, cut there, and we are told we have 90 degrees there. So it means we have a D, and here we also have 90 degrees.
Hello. Hello.
Hello? Hello? Are we together?
Yes.
Okay, wonderful. So now, from this triangle, there are few things which you must know. So let's say this is one, that is two. So the first thing that you can deduce from this second triangle we have, so it's the same with the triangle, it's just that with this triangle, so A2DC is a right angle triangle, A1DB is a right angle triangle, and ABC is a right angle triangle. So it means we have three triangles in this case. So, but now there's just one thing which we need to observe. So now the first one is that A1 plus A2 must be equal to which angle? A1 plus A2 in this case, you can see is given, it must be equal to what? It must be equal to what? 90 degrees. Because you can see we are told this is a right angle triangle. Therefore, if we add A1 and A2, that must be equal to a 90 degree. Remember, these are the information that is given from this triangle that we have. So now the other information that is given is that the side AD must be perpendicular to the side BC. So the side AD must be perpendicular to the side BC. And that information is also given there. You will see where we are going with this. Okay, someone is telling me that the screen is frozen. Is the screen fine now? Is the screen fine now? All right.
Yes.
Okay, wonderful. Wonderful. Okay, I was explaining that the addition of A1 plus A2 must be equal to 90 degrees because we have a right angle triangle, and then the side AD is perpendicular to the side DC because we are given a 90 degree. Then once we have 90 degree, it's a must that this line here must be perpendicular to that line. So now there's this information that you must know with regard to this Pythagoras. So Pythagoras, we apply it when we have right angle triangle. So there's this information that you must take note of. Then it's called the corollaries. These are corollaries. There are three of them. They are all deduced from this triangle that we have. Remember the assumptions we have made down there. So now the first corollary that you must know is that the triangle ABC is equivalent to triangle DBA. Let me explain this statement. Listen here. The triangle is ABC. The big triangle, the triangle ABC is equivalent to the triangle DBA. Why? Can any one of you give me a reason why we say triangle? Can any one of you justify this? Why do we say triangle ABC is equivalent? This is equivalent. It's equivalent to triangle ABD. Why do we say that? Is the screen okay? I'm seeing some messages on WhatsApp. Is the screen okay?
Yeah.
Okay.
Yeah.
No,
Okay.
it's you not on my side.
From your side, what's the problem? Can't you see what is on the board?
No, I can't see it.
Okay, let me see. Let me see what's the problem. Is it okay now?
Not yet.
Try to log out and then log in again. It must be fine because I logged this. Yes. So while he's logging in again, let me emphasize about this information we have. Remember, these are corollaries. So triangle ABC is equivalent to triangle DBA. The question is why? Why do we say those two triangles are equivalent? So let's check ABC and ABD. They share an angle. Can any one of you tell me the angle which these two triangles they share?
A.
Let's check. Does a triangle ABD have a full angle A? Remember, the full angle A is this one, right?
Yes.
Okay. Then it's not going to be A1 because it's not sharing the full angle. So the triangle ABD is just using this angle A1. It's not using A2. But there's just one angle which these two big triangles is
Angle B.
yes, angle B is common. So that's the first thing which you must know, that B in this case is common. B is common. So it belongs to triangle ABC and then belongs to triangle ABD. That's the very first thing. But there is another thing that is very interesting, that for the big triangle, the angle A is equal to the angle D, which, because both of them, they're what? They're equal to 90 degrees, right?
Yes.
Because of these two assumptions, you can conclude about angle A1 and angle C. What can you say about angle A1 and C, angle C?
They equal.
They are equal. Why are they equal?
Which angles?
Angle A1 and angle C. Why do we say these two angles are equal?
Angle A1 and angle C.
Yeah, angle A1 and C. Why do we say they are equal?
Angles in a triangle.
These are angles inside the triangle. Very true. You are very right with regard to that. So these are angles inside the triangle. All right. Where does this lead us? This leads us back to the theorem which I've covered with you, the similarity theorem. So if the angles are equal inside two different triangles, if the angles are equal for the two triangles, then you can then conclude about the proportionality of their sides. So this is what you can say. You can say the side AB divided by BD, let me say DB in this case. DB is equal to BC divided by BA. That is what we can say about this. Why? Because we have what? We have angles which are equal inside the two triangles. Then we can now talk about the proportionality of their side. So we now say AB divided by DB is the same as BC divided by BA.
Sir,
Yes.
I have a question for that. The theorem on top here, A1 is equals to C. Isn't
Yes,
it
yes.
supposed to be A2 is equals to C? Angle in the triangle.
It's A1 because we are talking about triangle ABD.
Oh, are we not focusing on triangle ADC?
Yes, we are not yet focusing on the triangle ADC. It's the second what do we call corollaries, wherein we'll be talking about the second one. So, but now we are focusing on the triangle ABD. So hence we say this angle A1 is equal to angle C. Where is this coming from? Because we know this angle D is the same as that angle there, and then the B is common. Therefore, we are left with no option but to say A1 is equal to C because these are angles inside the triangle.
All right.
Yes, and then from there, if two triangles have the same angle, then you can now talk about the proportionality of the sides. So, but now the proportionality of the sides, say AB divided by DB is equal to BC divided by BA. Let me write this as AB to avoid confusion. All right, after having that, you can then cross multiply. So the cross multiplication is what matters here, because that's what is all about all the theorems that we are doing, especially this one for Pythagoras. So it is this conclusion that matters most. So AB squared is going to be equal to BC multiplied by DB. Don't forget this. It's a very, very important conclusion which you must take note of. So if we have two triangles which are right angled and they achieve this condition, then you can now say AB squared is equal to BC multiplied by DB. Ask me a question if you do not understand about this conclusion.